Seb, we're very, very glad to have you today. For those of you who do not know Seb, I describe him as one of the probably 5 most knowledgeable people in the world on BDD, or as some of us, including Goico, prefer specification by example. But regardless of what you name it, Seb really, really knows it. So I am really looking forward to your talk today, Seb.
Thank you. Hello, good afternoon. My name's Seb. I work for SmartBear as a BDD advocate, and I would like to talk to you today about living documentation and why it's such a big benefit at the end of adopting a behavior-driven development approach to software. So, without further ado, let's go have a look at the agenda. First off, I want to make sure that we all have the same sort of understanding about documentation. I will, while going through that, offer some definitions of living documentation. After that, I'm going to do a brief introduction to behavior-driven development so that we, again, have the same level set about what we're talking about. As I do that, I'll introduce Cucumber. If you've never used Cucumber or tools like it before, then that will give you a grounding. Having finished the sort of background and level setting, I'm going to tackle head-on some confusion that I've seen about BDD and test automation. And then I think probably into the real meat of the presentation, which is the return on investment that you get from adopting behavior-driven development in your organization, and how living documentation is absolutely the pot of gold at the end of the rainbow. So documentation, I can't see you, so I don't know what you've got on your laps, whether you've got notebooks made out of paper or whether you have your iPads or something of that nature, or whether you're tapping away at your computer. Documentation's paper or electronic. In the old days, we used to have reams of paper that passed through different phases and different gates. Along the way, it got changed, and at each point that it got changed, someone was responsible for signing it off. Basically, some manager or senior person would go, yes, this is correct, whether that be the requirements or the designs or the test plans. And those signed cover sheets that we used to get on paper documentation and the same sort of electronic sign-offs that we use today gave us some confidence, or at least was intended to give us confidence, that that specification or design or test plan was in fact correct. It conformed to the requirements that had been asked for by the customer, and it delivered on the promises that we had made. Trouble is, the only connection between the paper or electronic documentation that we're signing off and the system that we're delivering is the person that's checking that it's correct. And with the best will in the world, any system that relies on repeated correct analysis by a human is liable to fail. And this is a weakness of modern documentation, of documentation typically. Goico Ajik, who Leslie just mentioned, said in his really excellent book, Specification by Example, that like cheap wine, long paper documentation ages rapidly and leaves you with a bad headache. This is an absolute perfect description of some of my experiences with documentation, but I think we should extend it and say it's not just paper documentation that ages rapidly. Anyone that's had fun playing with the wiki will know that electronic documentation ages possibly more rapidly. So let's start off with a thought experiment. I hope you haven't eaten too much lunch. So imagine that I was to give you a choice between having documentation for the system that you're working on that was unreliable, or having no documentation at all. Which should you prefer? So just think about that for a minute. Okay. And now I'm going to ask you a second question. Which have you got? My hope is, and again, I can't ask you, I can't see you, but my hope is that you said that you should prefer non-existent documentation, but that in reality, what you have is unreliable documentation. The thing about unreliable documentation is that it leads to confusion. Confusion about what's correct, about whether the system is right or the documentation is right. And like the picture of this gentleman in the top right corner, you might end up screaming or banging your head off a desk, or even, as the lyrics of this King Crimson song end, crying. Unreliable documentation is worse than no documentation. At least if there's no documentation, you have to go straight to the source of truth. If you don't have unreliable documentation, you will waste time looking through the source of truth and reacquiring knowledge, but at least you aren't doing work based upon a misunderstanding of what the system is supposed to do. So at this point, it's worth introducing a definition of living documentation. Last year, a French colleague of mine called Cyril Martrère published this book called Living Documentation. It's a big book. It's a big book and it covers all sorts of different styles of living documentation. And in this book, he offers up a set of 4 principles as a definition of what living documentation should manifest. And he says that living documentation should be reliable, low effort, collaborative, and insightful. Reliable, I think, goes straight back to my point earlier about unreliability. We want reliable documentation. That's indeed one of the first reasons for having living documentation at all. We want it to be low effort. Well, we want it to be low effort because actually what we've found in time and time again is if something is high effort, eventually someone's going to cut corners and it won't get done properly. It needs to be collaborative because there are always many people who need to consume documentation, and unless you write it collaboratively, it's likely that you will bake in some assumptions that you have that other people don't have, and that leads to misunderstandings. And finally, it needs to be insightful. So you can write brilliant documentation, but if it's not useful, it doesn't have an insight into what the system is trying to do, then it won't help you do your job better. So this is a great set of principles, and it's a great book, but the definition is just a bit too general for this talk. So again, I'm going to go back to Goiko's book and offer up his definition of living documentation as being a reliable and authoritative source of information on system functionality that anyone can access. It's as reliable as code, but much easier to read and understand. This definition absolutely condenses the important parts of living documentation, especially from a perspective of someone practicing behavior-driven development. So we've talked a bit about documentation, and we've had some definitions of living documentation. Now let's get some level setting around behavior-driven development and Cucumber. So behavior-driven development has historically been hard to define, but over the past few years, the community in general has come to a realization that in fact BDD is a set of practices, and in fact there are 3 core practices, and they are discovery, formulation, and automation. Discovery is where collaboratively we work to get a shared understanding of a user story. This discovery workshop is very similar, or indeed is often replaces the 3 Amigos meeting that many teams have adopted over the past 10 years or so. And the process in discovery workshop is to essentially have a structured conversation that brings together the business perspective, the development perspective, and the test perspective. And the idealized goal or output of a discovery workshop is a set of rules or acceptance criteria that define the scope of the user story that you're currently talking about. And for each of those rules or acceptance criteria, there should be one or more concrete examples that illustrate that rule. So the rule is abstract and high level and talks about what we're trying to achieve. And the examples are concrete and very detailed and enable you to essentially shine a bright torch into the dark corners of each rule to make sure that there are no ambiguities, no misunderstandings, no assumptions that haven't been mentioned. Once you've captured those rules and examples, you want to make sure that they can be used as meaningful documentation. So the rules will typically be textual, but the examples may have been captured as truth tables or sketches on a whiteboard or scribbles even. And so we need to somehow capture that in a way that people who weren't in the discovery workshop can then consume them and understand or arrive at the same understanding that people who did participate in the discovery workshop have already arrived at. And that process is called formulation. This is where the examples of system behavior that came from the discovery workshop are documented using business terminology. And using business terminology is important because that's the best way that the industry has found to ensure that everybody that's involved with the specification and delivery of a product can be included. If you capture those concrete examples using a structured documentation tool, such as the Gherkin syntax that we'll talk about in a minute or two, you can then get a computer to automate those examples. So essentially, you've found out how the system should behave in specific key examples. You've documented that using business terminology. And now, with a little bit of sleight of hand, you can run those examples as tests to demonstrate that your system, the system that you're delivering and developing, actually conforms to those specifications and delivers that functionality. One of the important things that I hope you get from this diagram, this circular diagram with directed arrows on it, is that discovery applies to each user story. And this is not a single phase of a product development. So it's not that we write all the user stories and then we run discovery on all the user stories, and then we formulate all of the examples that came out of discovery, and then we automate all of those formulated specifications. Instead, when we need to bring another user story up to the sort of level of understanding that means you can bring it into the next iteration or pull it into the in progress column, that's when you invoke the discovery practice on that story. So at any given time, you may be doing discovery on 1, 2, half a dozen user stories. You may be formulating 2 or 3 other user stories that have been through discovery in previous weeks. And you may be automating a number of scenarios that have been formulated earlier in the process. So the point is, this is not big bang phases. This is incremental and iterative, because behavior-driven development is designed to fit in seamlessly with agile ways of working. Having talked about BDD and a bit about the automation that is one of the core practices, it's worth talking now about how Cucumber works. Cucumber is by no means an essential tool to use when practicing behavior-driven development. However, it probably is the world's most widely used tool that assists BDD, and that's why I'm going to use it as an example just now. So the core concepts of Cucumber are that it works with feature files. Feature files are plain text files. There's nothing special about their content, normally with an extension .feature. And within those feature files, there are a number of scenarios. Each scenario has been formulated from one of the concrete examples that you discovered and captured during your discovery workshop. And those scenarios will have a number of steps in them. So each line is a step. pretty much. And those steps are introduced by keywords that you may well be familiar with, which are given, when, then. And these are English language words, which encourage us to write paragraphs and sentences that are business readable. Gherkin's a really, really simple syntax, a really simple language. It has a handful of keywords, but the bulk of it is made up of your own business terminology that comes from the problem domain that you are trying to solve with your solution. To automate these Gherkin scenarios, we need to glue the business text through to the application that we're trying to develop. And we do that by writing step definitions. These are small pieces of automation code which Cucumber will call for us in response to the steps that it finds in our scenarios. The core Cucumber project produces different versions of Cucumber that allow us to write these step definitions in some of the more popular languages of the day, such as Java, Ruby, JavaScript, Go. However, there are dozens more ports of Cucumber that have been done outside of the Cucumber open source project that are entirely compatible with Gherkin. So they use the same Gherkin parsers and they behave in pretty much the same way. And so with Cucumber compatible tools such as SpecFlow or Behat or Behave, you can also write your step definitions in C# or Python or PHP. I've given quite a lot of talks over the years, and one of the questions that often comes up is, does Cucumber support web applications? Can Cucumber call endpoints? Can Cucumber interact with rich desktop applications? And the answer that I give is frequently that, well, Cucumber, you can interact with all of those sorts of applications, but Cucumber doesn't support them itself. In fact, Cucumber knows nothing at all about your application. This green box is the limit of Cucumber's knowledge and interest. It reads the feature file, and in response to the steps that it finds in your scenarios, it calls the step definitions that you have written. And in those step definitions, you can do anything that you can do in code. And that might include interacting with a web application, maybe using Selenium or WebDriver, or indeed interacting with a rich desktop application, or quite often calling directly into application code. Anything that you can do in the language that you are writing the step definitions goes. Cucumber is merely the tool for calling that step definition. So, as we see here, Cucumber understands Gherkin. This is a minimal feature file. It doesn't make a great deal of sense, but it's a canonical example that comes from the Cucumber skeleton project. And I show it to you just so that we have something to look at. It's got, the feature has a name, the scenario has a name, and we have 3 steps: a given, a when, and a then step. And when you run Cucumber over a feature file, you can choose a number of different ways for Cucumber to output the results of that execution. One of the output formatters is called the pretty output formatter. And in the pretty format, it basically just prints out your feature file again, but this time it will color your steps either green if they have passed. So in this example, all 3 steps have passed, or it will color them red if one fails. And then it will output some diagnostic information as well. This is getting some distance towards living documentation. We have scenarios that express the examples that were discussed in Discovery. They've been formulated into business terminology, and they tell us if they conform to the system being delivered. So if they colored green, that means the system correctly implements what's being specified. But if they colored red, then we know immediately that there's some sort of problem. problem could be that there's a defect that has been written into the production code. The problem could be that the documentation, the specification is out of date. Or, given that this is behavior-driven development, it could be that we've specified this behavior, but the development team haven't yet implemented it. Any three of those might be the cause for a failure. It's getting towards living documentation, but there's a challenge, there's a problem. And that problem is this: where do feature files live? And the truth is that feature files must live in source control with the source code, because it's the feature files and the linked automation code that evolve and incrementally and iteratively guide us to develop more of the solution. They have to be versioned together. However, if you want your living documentation to be accessible to your business colleagues, to your product owner, to your customers, it's very likely that you won't want to force them to go into your source control system. In many cases, you may not even want them to get access to it, let alone force them in there. So we need to find a way of getting this documentation into a place where everyone that's working on the product can access it without having to jump through technical hoops, which then allows us to introduce another output formatter that Cucumber ships with, which is the HTML output formatter. This gives the same information, it gives it in a much prettier way, and it gives it as HTML files. This means that you are able to upload those HTML files to your wiki or to your intranet or wherever you like. However, it's a very manual process, or rather, it's got to be configured by you in your organization so that the files get put in the right place for people to find them. And if you want to do any extra work to try and show how the functionality of the product is evolving, or to try and analyze for scenarios that flicker, that sometimes pass and fail on a regular basis, that's again something that you'll have to do yourself within your organization. So recently, the Cucumber open source team have released a piece of functionality called Cucumber Reports. And so far, this functionality has been enabled in Cucumber for Ruby, for Java, and for JavaScript. And what it allows you to do is simply on your command line or in an environment variable, say you would like to publish the output of your Cucumber runs directly to Cucumber Reports. It really is as simple as that. And then when your Cucumber run finishes, all of the beautiful formatted reports are available at an obscure URL which gets output on the console. As you'll see from the printout here on the screen, the idea at the moment is that it's security through obscurity, and the report, if you don't do anything about it, will be deleted after 24 hours. Functionality is coming to allow you to claim reports, protect them with authorization and authentication. And at that point, it will become a truly useful piece of functionality for you in your organizations to distribute lovely documentation without having to do anything yourselves. The documentation looks very similar to the HTML output, but it's also bundled with a bundle of metadata, tells you about the operating systems it was run on, which version of Cucumber was used. And in fact, if this was run from a CI server, it would tell you about the commit that was run on and the server that was used. So if you are Cucumber users, I encourage you to kick the tires of Cucumber Reports and see whether it might be useful for you. So I've introduced a definition of living documentation. I hope I've given a very brief level set introduction to what behavior-driven development is, or what the 3 core practices of BDD are, and sketch the ground for what Cucumber does and why. So now onto the bit that might get me into trouble here. It's often with testers that I have the disagreement about test automation and BDD. So I hope we will still be friends when I tell you that BDD is not test automation. In fact, BDD doesn't have the same goal as test automation. The BDD practices of discovery, formulation, and automation are specifically around ensuring that we get a shared understanding of the story that we're about to develop, ensuring that we find a way of describing that behavior using shared business terminology, and then ensuring that we automate that specification so that the failing test can help the developers implement working code that satisfies that specification. To put it another way, BDD is an extension of TDD, where the tests are written in business language and collaboratively with the business, rather than writing the tests in a programming language and never sharing them with the business. So I've drawn a Venn diagram to try and emphasize or explain why I'm saying that BDD is not equal to test automation. Behavior-driven development comprises discovery, which is collaborative, formulation, where we grow our business terminology, and automation, which should be done by or with the developers. And the reason for that is because this automation is designed to guide the coding. That's where the first D in BDD comes in, behavior-driven development, in the same way as it's test-driven development. So this really means that you can't have a separate test automation team writing the glue code that automates the specifications and joins them to the application that you're building. Test automation, by contrast, is often after or in parallel to coding. That's my experience. It includes other forms of testing beyond testing the business-facing requirements of the application, such as performance or penetration testing. I've added exploratory testing into this slide after Elizabeth Hendrickson chastised me for saying that exploratory testing was only manual. And it's my experience that test automation isn't generally business readable. Certainly, test automation as an art or skill does not demand that the tests are business readable. So there's quite a lot of difference between BDD and test automation, and yet there is some overlap. And the overlap is that automated business readable acceptance tests are both a product of BDD and definitely fit into the definition of test automation. We've written a number of blogs about this on the cucumber.io blog site. So if you would like to follow up, please go and check that out at some point after the talk. So as a sort of segue into the ROI section, I'm going to ask you to think about the answers to a few questions. Does your team collaborate early and often throughout the whole life cycle, from requirements refinement to delivery? You can either say yes or no to yourself or jot it down. Are your Cucumber scenarios written and automated before the production code they illustrate is written? Again, a yes or no answer is ideal. I understand that the answer may often be sometimes or it depends. And then finally, does the use of the keywords given when then indicate that software is being developed using a BDD approach? Okay. So my answers, which may be different from yours, and if they are, I'd love to hear what your answers were. My answer is that BDD is by definition a collaborative approach to software development, and it has to start while the requirements are being discussed. This doesn't mean that BAs and product owners don't do front running, speaking to customers, doing focus groups, etc. But before we start writing a detailed specification, we need to get the test perspective and the development perspective involved. The second D, as I said earlier in BDD, stands for driven. The development is guided by the failing scenarios. The automation informs the design of the interface. It informs the design of the application. If you're writing the production code before the scenarios have been written and automated, then I don't see how it can be said that those scenarios or the behavior is driving development. And then finally, does the use of the keywords given when then have any indication that software is being developed using a BDD approach? And the answer, I'm afraid, is no. I've seen many tools and libraries over the past years arrive that use given when then as keywords within their domain and call themselves BDD libraries. But this has nothing to do with behavior-driven development. And in fact, behavior-driven development can be done perfectly well without Cucumber, without Gherkin, without using the keywords given when then. And the purpose of this was just to reinforce that if you said yes to the first two questions and no to the third question, you are very likely working in a behavior-driven way. But if you said no to either of the first two questions, then you are almost certainly not working in a behavior-driven way. And the third question, if you said yes to it, then I'm afraid that's just not right. Given when then does not indicate whether you're working in BDD or not. So let's move on to the return on investment of behavior-driven development. Why do people adopt BDD? So one of the motivators over the years for shift left and BDD has been a belief in Barry Boehm's cost of change law, first published in the mid-70s, where he essentially said that defects captured early on in an early phase of development were much cheaper to fix than if they were found in a later phase of development. And in fact, his claim was that if you found the defect at requirements, it was 10 times cheaper than design. If you found it during design, it was 10 times cheaper than finding it during coding, and so on. And so you end up with an exponential curve, and this one is a flat line because it's a log graph. So this is really good motivation, and I myself have used this on a number of occasions to justify the investment required to move from traditional agile development methodologies to agile development methodologies enhanced with behavior-driven development. But it turns out that it's possibly not true. So Laurent Bossavit, a French colleague of mine, wrote this really entertaining and informative book, maybe a dozen years ago now, called The Leprechauns of Software Engineering. And basically he takes a number of different truisms, things that lots of people in the software world, development world, believe are true, and then he digs into them to find out, is there any scientific justification for believing these things? And one whole chapter in this book looks at Boehm's cost of change curve, and he ends up with the conclusion, having followed all of the academic research impeccably, that it's a claim that while it has some surface plausibility and has gained widespread acceptance, it turns out on closer examination to be not just awkwardly vague, but almost entirely anecdotal. So this is not a justification this is not saying we shouldn't do BDD, but this is saying that the cost of change curve is not justification, or at least is probably not justification for adopting behavior-driven development. Instead, I'd like to look at the 3 different practices within BDD. So discovery is an early practice. It's a practice which is collaborative. It's, as I already said, it's designed to try and shine a torch into the dark corners of each story, each requirement, to ensure that we reach a shared understanding, and we've thought about corner cases, unsurfaced assumptions, ignorance that we might have that needs to be researched. And this is if you just go and do a discovery workshop on its own without doing any formulation or automation, I believe you get a huge amount of value. And as, again, not entirely scientific backing for this statement, I'm going to rely on some work done by a colleague of mine, Joe Wright, who worked with a team between April and November 2 years ago, and on a monthly basis got them to capture, well, every day they captured the amount of time they spent on different categories of work. Planned work, failure demand, which was caused because something they'd done previously had been done incorrectly. Ad hoc work, which is essentially people going, oh, I hadn't thought about that, can you do this please? And meetings. And in April, they were only spending 2% of their time going to meetings, but only 23% of their time was spent on planned work. Fully 70% of their time was spent in failure demand and ad hoc. And this was not the productivity that Joe was looking for in his team. And so over the 7 months, they started doing more meetings. They weren't actually doing discovery workshops in the way that I would recommend, in the sense of example mapping, which we can talk about in the questions if anyone's interested, but they were doing it through interacting with their stakeholders nonetheless. And after those 7 months, they had more than doubled the proportion of time that they were spending on planned work. The amount of time that they spent on failure demand was ridiculously low at 4%. And yet their meetings, they were spending 5 times more time in meetings, in these collaborative meetings, than they were beforehand. So what we're seeing here, that the return on investment of that 8% increased time spent in the discovery meetings resulted in more than 100% increase in acting on planned work. That's a massive benefit. Formulation is a place where we take the concrete examples that came from discovery and then collaboratively build a language based around shared understanding of business terminology. Eric Evans talked about it in his seminal book, Domain-Driven Design, and he called it a ubiquitous language. He said that it needs to be rooted around the domain model. And here he's talking about the problem domain. Because a lot of problems, a lot of rework, a lot of defects are rooted in the fact that people understand different things from the same word. And people often use the same word to mean multiple different things. Again, this is a very big book. There's a lot in it. However, this little nugget about ubiquitous language, this is the value of formulation. It's a loop where we take examples that we have agreed on in sketches, and we generate a business-rooted language that we can all have a shared understanding of. We can have this communication between different roles without ambiguity. This is a big return on investment. And then finally, automation. So if you have automated tests guiding development, then it encourages developers to work on the pieces of functionality that make those tests pass. Not on gold plating, not on things they think they might need in the future, but actually the work that needs to be done to satisfy the next highest priority requirement. You also get reliable documentation, because this process allows us to take the business readable specifications in the feature files and link them or verify them directly by automating them against the system that you're building and delivering. And this means that you get the benefit that your documentation will tell you if it's out of date. No more unreliable documentation. And finally, it gives a business-focused safety net for developers. Developers make changes. They want to know if they've broken something, and they want to know as quickly as possible. They need fast feedback. Their programmer tests, their unit tests can and do give them some of that confidence. The trouble with a lot of programmer tests is that they are focused around the implementation level. So the implementation may work, but it still may not satisfy the acceptance criteria, not satisfy the business needs for the system. So these are the benefits of BDD. This is the return on investment of adopting BDD. But there's more. BDD gives you a huge amount of benefit. Living documentation is an extra set of benefits that you get over and above those return on investments that I have just described. Living documentation is a way of delivering transparency. So anybody in the organization can look at your living documentation and immediately see what functionality is currently supported in the product. If they look at the living documentation over time, they can see how it's evolved. They can see which bits are error prone. In fact, business can even use the living documentation to speculatively create scenarios that investigate what would happen in situations that they've only just thought about. It's a truly excellent way of delivering transparency. I was really happy to hear in the keynote, Mike talking about confidence, because this living documentation inspires confidence throughout the organization and outside. If you publish your living documentation and you let your customers see it, they can see how the product is evolving as well. They can watch progress in real time. And as I said earlier, it gives confidence to the developers to know that the latest change or enhancement hasn't broken anything, but it also gives confidence to your project managers and your business stakeholders. Confidence, that's a huge benefit. And then finally, continuity. So I think it's unlikely that many of you have there's too many negatives in that statement. Many of you will have picked up projects that you weren't on at the beginning. Not all projects are greenfield sites. If after 5 years of having been deployed, a product then needs enhancement because a new regulation comes along, the chances are that the team that is tasked with adding this new regulatory functionality was not the team that originally developed and deployed that product. And historically, this is a dangerous place to be because the unreliable documentation of the past would either lead you to make assumptions that were not borne out in the system itself, or would force you to go and reverse engineer vast chunks of code that you didn't write and you don't like reading to try and work out what the system actually does. Living documentation drastically and dramatically reduces the cost of onboarding new teams, which allows you to potentially outsource, but equally allows you to reduce the cost of maintenance, even if you're using in-house teams to do that enhancement. These three properties of living documentation are significant benefits. They're not all tangible in the sense of we can put dollars and cents on them, but they are logical and visible and make for a much happier workplace. These transparency, confidence, and continuity are the properties that sit within the pot of gold at the end of the BDD rainbow. So, to wrap up properly, living documentation is reliable and accessible. It's correct, and it can be read by anyone who has any problem domain knowledge. Living documentation, and indeed BDD, is distinct from test automation. One is not better than the other. They are just different things, despite there being an overlap. Living documentation reduces the cost of developing, maintaining, and enhancing software, both by the confidence that it gives developers when they're writing code or making changes, but also the strength of being able to onboard new developers cheaply, pass maintenance of this software to other teams. It's a massive benefit. And finally, the great thing is that living documentation is a free byproduct of the BDD core practices. If you adopt discovery, formulation, and automation in your software development lifecycle, by definition, you will get living documentation as a secondary output. You haven't put any extra effort in to generating that living documentation. You put effort into ensuring that you understand what you're being asked to do. You put effort into making sure that you have a shared, unambiguous terminology that the whole team can use. And you put effort into writing automation code that enables the developers, drives out and guides the developers as they write their production code. None of those things are focused on living documentation. Living documentation is the free byproduct of BDD core practices. Thank you very much for coming along to this session. In the top corner here, a couple of books that myself and the creator of SpecFlow have written, called Discovery and Formulation. And if you're interested, they're available both in electronic copy and hard copy if you visit bddbooks.com. And now, if there are any questions, I would be happy to take them.
Seb, there are a few questions. First question up from Rohit is, should Cucumber tests be written by developers or quality engineers or both?
So the Cucumber tests, and by that I think you're probably meaning the scenarios in the feature file, they should be written by whoever you've got to write them. So the formulation, so maybe I need to be clearer here, because discovery is collaborative. You need to have representatives of test, development, and business in the discovery workshop. The concrete examples that come out of that need to be turned into business language, written in the given when then format that can be understood by everybody. And so that means they need to be reviewed by everybody. It's not ideal if you say, oh, the testers have to write the scenarios. It's not ideal if you say the product owner has to write the scenarios. And it's not ideal if you say the developer has to write the scenarios. The real ideal is that we have a separate collaborative activity where together we write the scenarios. The trouble is, it turns out that getting language just so is not easily achieved when lots of people are trying to talk together. So the recommendation that we make with clients that we work with is that we have a developer tester pair that will take the examples that come out of a discovery workshop and formulate them into Gherkin. The resulting Gherkin is then reviewed by the whole team, and that includes other developers, other testers, and business stakeholders. So the first draft we recommend should be written by a pair comprising of one tester and one developer, but subsequent drafts will be updated based on feedback from the whole team. If, however, you were talking about the automation code, then the automation code has to be written by someone involved in development, because it's a part of the design process of the production code.
Okay, we've got a question here from Anthony who says, right now my team and I are trying to find a way to sunset manual tests after they are converted to automated tests. Do you have any advice on this?
Yes. How long have we got? We've got not very long. So the first thing is
5 minutes.
5 minutes, yeah. So Cucumber might not be the right tool for doing that. So you have to understand, what are you trying to do with your tests? The reason that Cucumber is a useful tool is because it can be written using business language, and you can engage with your business colleagues while you're going through the discovery phase, while you're going through formulation. If you have a whole bundle of manual tests and you want to automate them, you have a number of problems, and Cucumber itself doesn't help you solve those problems. The first and major problem that I see when we try and do this is that manual tests are frequently optimized for testers' time. So you will bundle multiple, testing multiple behaviors in a single test because you want to make use of a single setup, and then try and make sure that you don't have to run that setup multiple times. Whereas if you're working with automated tests, you probably have a different area that you want to optimize. You want to optimize for really clear signals from the automated tests. So in general, when we're looking at Cucumber scenarios, we're looking for tests that are 5 steps or fewer, that each step focuses on a single rule, a single acceptance criteria. There are very few Cucumber tests that go across the whole user journey. And this is normally a contrast between manual and automated. So my recommendation would be that whatever it is you're trying to do, whatever sort of manual test you've got, the first thing you need to understand is, what is your goal? Are you looking for fast, focused tests that will give you confidence and be easy to maintain? Or are you looking for as cheap a transition as possible from manual to automated? And once you've asked yourselves that question, then I have the answer that you should get to. I suggest that the answer should be that there is no good value in taking manual tests and then automating them directly line by line. I've seen a number of organizations that have whole teams of automation engineers whose only job is to nurse the automated tests back to health every morning after they've broken during the nightly build. Manual tests are maintainable because there's an intellect using those manual tests, thinking about, what is this action? Oh, that label's changed on the screen, but I know that it actually refers to this label in the manual script. Automated tests are not intellectual like that. They cannot see those links. And then what you find is you have long automated tests that are brittle and expensive to maintain. And that goes for record and playback technologies as well. It seems like a really easy way to take a manual test and automate it, but there will be pain, and that pain will not be a long time coming.
Seb, the other comment we have here from Charles is BDD, BEM curve, and word meanings all tied together, and he loves it. Thanks for a terrific presentation. And Seb, I would second that. Really, really good stuff in here. Thank you.
Thank you.